We are now going to hear from David Gold from IBM. So talking about exciting things and new models. David, tell us a little bit about you and your role with IBM.
Right. So I am the lead atmospheric scientist for IBM Consulting. I've been with the company for a little over 7 years. My group specializes in helping clients who want to gain insights from weather and climate. And sometimes that involves the kind of models that we're showing off here today.
All right. So weather, climate, how is this being applied in well, actually, first, before we go to the application, tell us exactly about this collaboration that you have with NASA, right? It's NASA, the collaboration, yeah?
Yes, that's right. Yeah, so a little over a year ago, I believe, IBM began working in a collaboration with NASA to train a foundation model on a large amount of geospatial data, specifically harmonized Landsat Sentinel data. This is basically a set of data from space-based remote sensors, the two satellites that are in the name, Landsat and Sentinel. And this gives you an effective spatial resolution of roughly 30 meters and a temporal resolution of about 3 days. Petabytes of this data. Okay, think about the volumes of data involved in training a model like this. But
sorry, a petabyte. You've tell how many zeros?
Okay, so a petabyte is 1,000 terabytes. So if you think maybe that helps, so it's a million gigabytes.
Yeah. Million gigabytes. Okay, all right, a petabyte.
Yeah, petabytes of data. And by training a large model to do a fairly simple task, which is to reconstruct these images, these rasters where we've masked out pixels, the model learns a whole lot of other things. So it learns about a lot of spatial and temporal relationships within the data that then allow you to very quickly train models for specific tasks, including flood detection, fire scar, the aftermath of wildfires, which of course is a big deal. So that's what this model can do. It can basically generate a lot of models to solve for many different downstream tasks.
Okay, so we're kind of seeing, if I'm understanding correctly, we're seeing imagery essentially in a 30 meters at a pop, if you will,
right.
And 3 days worth of sort of imagery in a sequence, yeah.
Right.
Okay.
Right. So every 3 days.
Every 3 days. So how is this data then being utilized? How is it being used in the context of, let's say, a development program or a development use case? Maybe kind of break down an example or two.
Sure. So as I was alluding to earlier, you train this model on this massive quantity of this data, and you actually then build something, an AI, a generalist AI, that can then be fine-tuned on relatively small amounts of data from either the same data set or other data sets. So for example, you can expose to this a relatively small number of flood events, and from that, you can then run it anywhere in the world and you can detect a flood after it's occurred. But one of the things that makes this useful is because it's in a geospatial context, you can merge it together with other kinds of data like built infrastructure, crops, and you can immediately detect impacts.
So this has some real practical application for development contexts. And if I've understood correctly, so we're talking about something that is open source, but also accessible through an interface that IBM develops and makes available through some license or commercial agreement or something along those lines, yeah?
Right. So IBM has recognized that there's a lot of complexity in geospatial and weather and climate workflows. So they're trying to abstract a lot of that away for the user. And so while anybody can go onto Hugging Face and grab the model weights and go to town, for those that want the full experience, there's a whole tech stack there that handles the entire process and lets you, for example, select your use case, lets you fine-tune your own model. It'll even in time allow you to go upload your own data.
And how can folks find out about this if they're tuning in from anywhere in the world right now, how can they learn more?
You can actually go to IBM's website and find good information on this effort.
What's it called?
I would go to just do a Google search for IBM and NASA Geospatial Foundation model, and you'll immediately find it. You can also go to Hugging Face and look for the model, and you'll find it.
Okay, wonderful. David, thank you so much for stopping by the pop-up studio and for sharing this. It's absolutely fascinating stuff.
Great. Thank you. Really appreciate it.
Awesome.